Here we go, folks. 8-3, finding volume of cones. Volume, little bit different than volume of cylinders. Volume of cones. I love me some ice cream cones, and we're talking about the cones that look like the sugar cones. Not the old
butterscotch ice cream.
Ooh, that's good stuff there. All right, here we go. Example 1, page 432. 432. Talking cones, baby.
How is the volume of a cone related to the volume of a cylinder?
It must be similar.
Think about this question during the lesson.
Similar, but not the same.
Kiara is filling a cone-shaped pastry bag with frosting from a cylinder-shaped container. They are both 5 inches in height and have a 4-inch diameter. How much frosting can the pastry bag hold? How can Kiara determine how many times she can fill the pastry bag?
That's interesting. That's a great question. Well, how can we determine? Well, let's fill them up, see how many times we can fill it up. But there's going to be an easier way. Okay? We're looking for what's the relationship here between this that has the same height and diameter as this cone over here. There we go. It's getting good.
Draw a cylinder to represent the container of frosting and a cone to represent the pastry bag.
Okay.
Like a pyramid, a cone comes to a point. However, a pyramid has flat, triangular faces, while a cone has one smooth, curved face.
Smooth.
A pyramid has a polygon for a base, while a cone has a circular base.
Circle.
Both the cylinder and the cone are 5 inches tall. Their bases are 4 inches in diameter, which means they each have a radius of 2 inches. The volumes of a cone and a cylinder with the same base and height are related. It's the same relationship as the volumes of a pyramid and a prism with the same base and height.
Huh.
What fraction is the volume of the cone compared to the volume of the cylinder? Select your answer.
I know you guys are all ancient Egyptians, and you guys built many pyramids, okay? And they're talking about relating pyramids to square prisms or rectangular prisms. You know what the fraction is? It's not 1/4. Nope. It's not 1/2. It's not even 2/3. A cone, folks, is 1/3 the volume of a cylinder.
Oh.
So the cool thing with all this, all we have to do is find the volume of a cylinder, but then multiply it by 1/3. 1/3! What if you didn't want to multiply by 1/3? What number could you divide by?
1.
No.
3.
3. You could also divide by 3, but we're going to multiply by 1/3, everybody.
The volume of the cone is 1/3 the volume of the cylinder. The volume of a cone equals 1/3 times the area of the base times the height. Find the volume of the pastry bag. The base is a circle, so the area of the base, B, is equal to pi times r squared. Use 3.14 for pi. The radius is 2 and the height is 5.
Okay.
Finally, use your calculator to find the approximate volume. The pastry bag can hold about 20 and 93/100 cubic inches of frosting. Because the volume of a cone is 1/3 the volume of a cylinder, the bag can be filled exactly 3 times for the container of frosting.
That's wonderful. I love frosting. I like when this thing plays.
Now you know how to use the relationship between cylinders and cones and the formula for the volume of a cylinder to also find volumes of...
All right, my friends, so let's take a look. It says find the volume of this cone. Nice big cone here. 1.5 inch on the radius. Okay, 4 inches on the height of that cone. Let's fill in some bubbles. Hey, to find volume of a cone, we find the volume of a cylinder, which is what pi times the radius squared times the height is, but we have to multiply that by 1/3. Okay, there's our formula. Look at your formula sheet, page 21 in your packet. Okay, you'll see that for cones. Volume is equal to 1/3 times pi times the radius squared times the height. Okay, let's keep filling in the bubbles. Well, this is 1/3. times 3.14, we need the radius. Well, that's easy. It's 1.5. So I'm putting that in there for the radius. Times 4. Well, 4 is the height. Okay. Next up. Well, I don't know what they want to go in these next ones. I know what they want. Okay, 1/3 staying there. 1.5 squared. I think it's 2.25.
2.25. It is.
Okay,
Yes.
this is 2.25. Next up says use your calculator and calculate. So 1/3, 1/3 times 3.14 times 2.25 times 4. Oh, okay. It's approximately 9.42. The volume of the cone is about 9 42/100 cubic inches. Okay, there it is. There's example 1, my friends.
Nice job, people.
Thanks. Let's go to example 2. There it is. Example 2. This one. Loading.
Midori has a cone full of birdseed to feed the birds at the park. What is the volume of the birdseed in the cone?
Look here. You guys thought we were done with Pythagorean theorem? How can you use the Pythagorean theorem to find the height of the cone? Well, folks, I hope you look and see. We have a right triangle here. They're given what's called the slant height. We don't use the slant height to find the volume. We use the height of the cone, which is from the center of the circle straight to the point of that cone. We got to find that side. So basically, I'm going to take and redraw this triangle. Okay? We have the radius, which is this part. This is 7 centimeters. This part here, we don't know. We know the slant height, which is 25. And we need to solve the Pythagorean theorem. Use the Pythagorean theorem to find the height of the cone. Now, I'm just going to, Mr. Priggy, I know he doesn't care. I'm going to use the book to show the work. Hey, that's what it says there. Oh, look at that. They use R and H and L instead of A, B, and C. Same thing, just different variables. They substituted in for the one leg, 7. The other leg, the hypotenuse, 25. We're solving for the other leg. They squared those sides. What's going to be the next step to solve for H? You're right, we're going to subtract. Look what they do. They subtracted 49 from both sides, left us with 576. What's the last step to solve a square equation? You find the square root. That's right. So they took the square root of 576, comes out to be 24. So this thing has a height. This height right here, 24 centimeters. Now we have a radius. Now we have a height of the cone. And let's keep going. Look what's next. Okay. Now, in this problem, this is just another value for pi. 22/7 is another way to calculate pi. 22 divided by 7. Oh my goodness, it comes out to be 3.1428. But again, just another approximate value for pi that sometimes they will tell you to use. So this time they say use 22/7. So instead of pi, this time they used 22/7. Substituted 7 in there for the radius and 24 in there for the height of the cone. Type it in, press enter, boom. That thing's about 1,232 cubic centimeters of birdseed. Everybody loves some good birdseed.
Especially the birds.
Okay, more so the birds than me. All right, let's go to example 3. I wonder what we're going to do now. All right. Now they're giving us the circumference of the base of the cone is 6 pi inches. What is the volume of the cone in terms of pi? Oh, this looks like fun. So they give us the height. They give us this circumference as 6 times pi. I wonder what we can use that for. Well, let's see. Okay, step number 1. It says use the circumference to find the radius of the base. We've been using this formula for quite some time now. The circumference is equal to 2 times pi times the radius. That's how you calculate the distance around the circle. What did they substitute in there for the circumference? 6 times pi. Equal to 2 times pi times the radius. Solve the equation. Now, what can we divide both sides by? They combined it all into one step. Mr. Fricky would probably like you to do it in 2.
I'm okay with 1.
You're okay with 1?
Yeah.
Okay.
Because we talk about adding like terms. What's 6 pi plus 4 pi? You know?
Okay, so they divided both sides. Okay, if you look here, they divided by 2 pi on both sides.
Yeah, you're allowed to do that.
Well, when we divide 6 pi by 2 pi, well, the pi's cancel out. I love me some pi, too. Okay, and what's 6 divided by 2?
3.
3.
Do you like
Yes.
butterscotch pie?
I've never had it, but I'm sure I would. Okay, the radius of that cone is now 3. Okay, the radius is equal to 3.
Now we're home free.
Now it's easy. We have the radius. Do we have the height? That's the only 2 things you need. You need the radius, you need the height. Substitute it in there, boom, look what they did. 1/3 times pi times 3. There is our radius, and there is our height. Type it in, it says in terms of pi. Now what I tell my kids, if we're calculating things in terms of pi, multiply all the constant terms together, leave pi out of it. So 1/3 times 9 times 13 gives you 39. And then we have to multiply by pi. So this would be 39 pi. 39 pi's. Wow. Questions?
Nope.
Okay, second part of that says find the volume of the cone. Okay, here we go. I'm sorry, I said second part. First part of the try it section. Find the volume of the cone. It says estimate using 22/7 for pi. Okay, so I'm going to start with writing down the formula like all good math kids would do. 1/3 times pi times the radius squared times the height. Once you have it down, calculate and plug in the information you need. Okay, 1/3 times, they say use 22/7 for pi, so 22/7 times the radius. Oh no. Oh no. We don't have the radius.
Wait a second.
This is what example 2 was telling us to do. But we do have what type of shape?
A triangle.
That's right.
A
More
right
specifically, a right triangle, where we know one of the legs and we know the hypotenuse. So we know one leg, we know one hypotenuse. Do you want to use the R and the H? Well, and they used, instead of a C, they put an L there for slant height.
Oh boy.
Yeah, that's what they used, but we can make sense of it. This is the height, so I'm going to plug this 3 in for H. This is your slant height. See, it's slanted. Okay, it's 5. We don't know what the radius is. Well, let's solve that bad boy. This is Pythagorean theorem stuff, my friends. This is 9, so r squared plus 9 is equal to 25. Take 9 away from both sides, and you guys have done this enough. We're left with 16. Okay? What's the square root of 16? 4. So our radius, this is 4 millimeters. So I'm going to plug 4 in there for r. And what's going in there for the height? 3. And now we got to just type it in. 1/3 times 22/7 times 4 to the second power times 3. It says express answer as a fraction. Your volume, 50 2/7 millimeters cubed. Cubic millimeters.
Cubic.
All right, there's try it part A. Let's go to try it part B. Man, only thing better than try it part A is try it part B.
You're right about that.
Okay, express the volume in terms of pi. Okay, well, let's start with writing the formula down. I know you guys love doing this. Oops. times pi times the radius squared times the height. Well, let's substitute what we know. I know 1/3 expressed in terms of pi, so I'm just going to leave in pi. I need the radius. Do we have the radius? Oh, stinkers. They don't give us the radius. What do we got to do? They'll always give us enough information. Now we need to find the radius. They give us the circumference. We know circumference is equal to 2 times pi times the radius. Substitute what we know. Hey, this circumference, C, is 16 pi. So where the C is, I'm going to put 16 pi. And I got to solve this equation for R. What can I divide both sides by? You got it. Divide by 2 pi. Divide both sides by 2 pi. That would leave me with 16 pi divided by 2 pi. Well, the pi's cancel out. What's 16 divided by 2? 8. So your radius is equal to 8. Got it? Radius, 8. What is this? 8 feet. So there's our radius, 8 feet. So I'm putting 8 in there. My height, that one's easy, 21. Now it's start multiplying. But again, in terms of pi, so I'm not going to multiply by pi.
No.
I'm just multiplying the constant terms together. So 1/3 times 8 squared times 21. And this comes out to be 448.
Pi.
But we still have to multiply by pi, so I'm going to add it on there at the end. Give it a unit, cubic feet. We now found the volume of that cone in feet cubed in terms of pi. There's through 432, 433 for you. I took a long time. Mr. Friggy loves that because that was just me teaching it up, boys and girls. You guys have a great day.